So let's look at some triangle theorems. There's a triangle. We know, of course, that the angle sum of the triangle is 180. Okay, so in other words, angle A, B, notice I just called them A, B and C because there's no ambiguity there. So A, B and C add up to 180, reason angle sum of a triangle. Well, let's go prove it. I want to prove those three things in 180. In order to do that, I'm going to construct another line. I'm going to construct DE parallel to BC and it passes through A. So DAB and ABC would be the same. They're alternate angles. EAC and ACB are the same, alternate angles. I know there's a straight angle there, DAE. So those three angles will add together to give 180. Oh, by the way, those three angles. And this is why you definitely can't use the term supplementary angles. Because supplementary angles are two angles that add together to give 180. I have three angles that add together to give 100. So they are not supplementary angles. Substituting in, we have our proof. It amazes me how many people forget this theorem, the exterior angle of a triangle theorem. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I can simply say angle ACD is equal to angle A plus angle B. It's the exterior angle of a triangle. That's the theorem I'm using. Now, a lot of people waste time by going angle sum of a triangle and finding ACB and then doing, or angles on a straight line and then coming up with it. You can do it all in one hit using the exterior angle of a triangle. So let's prove it. Again, I'm going to construct in a new line there. So CE parallel to BA. ABC and ACD are corresponding. BAC and ACE are alternates. ACD, well, I can write that in two ways. I can write it as ACD, or it could be the sum of ACE and ECD. And so there we have it, substituting in. So some polygon theorems. We know the angle sum of a triangle is 180. Well, angle sum of a quadrilateral we know is 360. Again, I name the shape A, B, C, D. I don't draw a little picture of a box. That's not an acceptable abbreviation. How can I prove it? Well, I can prove it by simply drawing in the diagonal. And now instead of looking at the shape and saying, hey, there's a quadrilateral, I can look at it and say, hey, there's two triangles. And I know the angle sum of one triangle is 180, the angle sum of the other one is 180, so if I add it together, the angle sum of the shape is 360. And I can do that for any shape. There's a pentagon. I could draw in both its diagonals. There we go. And I've chopped it up into three triangles. And each of those triangles would have an angle sum of 180, giving us a total of 540. So in fact, any polygon can be turned into n minus 2 triangles. Exterior angle of a polygon. The interesting thing with the exterior angle of a polygon is that they all add up to 360. So the total angle sum of all the exterior angles is 360.